Okay, let's keep going then. So we also have that TVM solver, right? We also have this TVM solver, and we're going to solve it that way as well. So again, it's the same problem. We're going to use the TVM solver. So it's the same word problem. Okay, if you remember with the TVM solver, there was, different notation. There was notation there, certain things that you had to put into it. PV was one of them. That is the initial balance, the initial amount in the account. That's going to be negative here because that's money in the account. It's not money that we have, so to say. We don't have it directly in front of us, so to say, if that makes sense. We're still looking for PMT. That's still unknown. FV is going to be 0. Remember, that's how much will be in the account after the process is done, in the future. Well, after this whole thing happens, we want to run through all the money, right? So that's going to be 0. I, remember, that's our interest, but you leave it as a percent, though, which is 6%. In the TVM solver, capital N is little n times t, which in this case is 1 times 40. Right? It's because we're making annual withdrawals once a year over 40 years. It's basically how many compounding periods there are, which is equal to how many withdrawals we're making. Once a year over 40 years. These are both equal to 1 because we're making 1 withdrawal a year. So it's being compounded once a year. And these are always equal to each other. This is how many times it's compounded in a year, which in this case is 1. And these are both always equal to each other. Let me just show you the TVM solver. All right, I gotta stop sharing these notes. Okay. No, it wouldn't work. Okay. Okay, here we go. Here it comes. Okay, so this is our TVM solver, right? We said N, remember that's 1 times 40, which is just 40. We said the I was 6%. Okay. PV we said was negative 500,000. Good. PMT is what we want to know. FV, we want that to be 0, right? Because that's what we're solving for. No, excuse me, PMT is what we're solving for. We said FV is 0. That's how much is in the account after this is all done. Well, theoretically, we want to run through all the money we have for retirement. So we leave that as 0. These are both equal to each other, and they're equal to how many times we take out money or make deposits, depending on the question. It's also equal to how many times the account is compounded, which in this case is once a year. Solving for PMT, we get the same thing. We get $33,230 and 77 cents, the same amount, as you can see. I know you might be thinking, what if I forgot to make PV negative? Would that make a difference? Well, if we did, let's say for some reason we had this as positive. The only difference here is that this would be negative. But you're not going to take out a negative amount of money. So the answer would just be $33,230.77. I mean, in the context of the question, the negative does mean something. But in this question here, you can really just leave that negative sign off. Okay. Are there any questions about this? I mean, make sure you're reading the book as well. They do a lot more examples. So, all right, let's keep going. Okay. So again, this is what we got, $33,230.77. Okay. Just like before, that's what we expect. in the past, I allowed students to use the TVM solver. They just had to fill in what each of the variables are. You know, what is your n, what is your I, all that stuff. All right. So here's one I actually want everyone to try. So what I'm going to do is I'm going to pause the recording, and we'll take about 5 minutes. Here, what you're going to do is you're just going to answer this question. Let's say we want to withdraw $1,500 each month. So from our account for 25 years. And the account is a retirement account, right? We're taking many withdrawals, so it's a payout annuity. It's earning 6% interest. Here, the question is, how much do we need in the account when we retire? Okay, that's what we want to know here. How much do we need in our account when we actually retire? Okay. Now, notice here also, let me just do this quickly. Here, you want to calculate P0. You know what PMT is. The other values here, you know. P0 is actually what you're calculating. Okay, so what I want everyone to do is just right now take about like 3 or 4 minutes to calculate this and use the formula, okay? Or you can use, I guess, the TVM solver. I'm going to go through both ways. So let me just pause the recording.